Endonino, and I am an associate professor of anthropology at Eastern Kentucky University. And tonight, I'm going to tell you about my other long-running archaeological research project. I got a couple, but this one is focused specifically on the late archaic Thornhill Lake phase of Mount Taylor mortuary mound complex at Tomoka State Park. Now, I started off in my journey into studying late archaic mortuary mounds at the Thornhill Lake complex over on the St. Johns River. And that led me to looking at the Tomoka complex. They have essentially contemporary burial mounds, and both have similar assemblages of banner stones found in the mounds and presumably associated with burials, confirmed at Thornhill, suspected at Tomoka. So my dissertation research led me to Tomoka, and that's where I've been doing most of my Florida work since about 2013. Now, the Tomoka complex is located on a peninsula, and it's located in far northern Volusia County, and it's bordered on the east by the Halifax River and on the west by the Tomoka River itself. You'll notice that there's a creek running along adjacent to the site. That was dredged in the 1950s, and that's Strickland Creek. Prior to that dredging, it would have been just salt marsh from the paleo dune that the site rests upon, all the way over to the Tomoka River. I got a lot of slides tonight, so I might not spend a lot of time on all of them, but I'll make a pretty good effort to get through them all rather expeditiously. So the Tomoka complex, as I mentioned, has mounds. It's got banner stones, and as such, it captured my attention pretty early on. And previous research was done by A.E. Douglas in the 1880s, and he called the banner stones ceremonial axes. He blew out the entire eastern side of Mound 6, the biggest mound, in a very wedge-shaped pie-like excavation. But he found 2 caches of banner stones. The first one about 2 feet beneath the surface, 3 of them grouped together, and then 3 feet below that, 5 banner stones grouped together edge to edge. And he found a pendant on the surface of the mound made from the wing of a broken banner stone during clearing prior to excavation. For a while, we didn't know where these banner stones were, but some sleuthing showed that they were in the American Museum of Natural History, but labeled or placed under the wrong site name. So we found almost all of them. There's still some that are MIA, and we're working on tracking those down. But the site consisted of at least 7 to 9 mounds. When I started my work there, there was some confusion about exactly how many there were. Randy Daniel visited the site in 1979 for the Florida Park Service and mapped it out and said that there were 9 mounds, but there's so much undulating terrain out there, there could be more. I found another one. Well, 4 actually, but I'll clarify that going forward. So I initiated the Tomoka Archaeology project in 2013 with some very simple goals, at least for the beginning stages. I had anticipated there being multiple stages over many years, and we're on year number 8 now. And so I can see the 3 stages, sequentially building upon one another. The first one, super simple, and I engaged my students and volunteers in that work back in 2013 with a very helpful grant from the American Philosophical Society. And so the goals of the first stage of work: how many mounds are there and how old are they? Critical information. I needed to know those things before I could refine my methodologies, formulate more nuanced questions to ask of the site and the features there, requiring me to know how many mounds are there and how old are they, because I'm really interested in the Thornhill Lake phase of Mount Taylor, which, if you haven't looked into it any further, they're very likely some of the, if not the oldest mortuary mounds in the southeastern United States. They're slightly younger than the mounds in the Mississippi River Valley, but theirs don't have burials, ours do. So simple questions: how many mounds, how old are they? The results of the first stage of research were encouraging. Mount Taylor Late Mount Taylor, Thornhill Lake phase shell deposition and mound building was between about 4,963 and 4,256 cal BP. And that's all based on a series of radiocarbon dates from the mounds and other mounded features that we excavated. While we were there, we also tested other locations that are not Mount Taylor in age. And so from the first stage of work, we also had a St. John's 1 component, about 3,300 cal BP on midden deposits and about 1,200 cal BP as an association with a mortuary mound building context at the site. So the Thornhill Lake phase mortuary mounds, which I'm specifically interested in, range from an early end of 4963 to a late end of 4447 cal BP. And that much younger date was from Bruce Piatek's work back in the early 1990s. But based on comparisons of the dates for all the mounds, it's likely between 4850 and 4700 cal BP when you take the radiometric assays and the diagnostic artifacts, the banner stones, which according to Ken Sassaman and Asa Randall are from their phase 2, the Savannah River Valley, which is 5200 to 4700 cal BP. So we can narrow the range down when we throw in the diagnostic artifacts. And as I mentioned earlier, the St. John's component during this first stage was between 3,300 and 1,800 cal BP. And here's a LiDAR map of the site. In the first stage of work, we started to map this the old-fashioned way with terrestrial-based land surveying, and that quickly ground to a screeching halt when it was brought to my attention that there's LiDAR data. So we abandoned the old style of topographic mapping, and now we just use the high-tech stuff. But the high-tech stuff doesn't have the best resolution. So in December, I'm heading out there to do some drone flights over the Tomoka complex and map that using LiDAR. So we'll have hopefully 1 to 2 centimeter accuracy in future maps. But here's what we got. We discovered some new mounds, mound 10 over here along this old ridge, a low shell mound, and then mound 3, which is numerically not an old mound, but the previously designated mound 3 is a looter pit that had a slightly moundy appearance, but our excavations in stage 2 clearly demonstrate that it's a disturbed context, it's a looter pit. But we found a new mound in the woods, mound 3, and it has both St. John's and Thornhill Lake phase components. So that's pretty exciting. And our LiDAR map and some boots on the ground ground truthing showed that we also have a shell ring up at the north end of the site. And I'll come back to that towards the end. So that's kind of where we were at the end of the first stage of work, necessary to figure out the chronological history of the site in terms of its formation, deposition, and the major topographic features that were there. So the second stage of research, we began that in earnest in 2016. And we did that with grant funding from my university, Eastern Kentucky University, through a faculty development grant and through funding from a special category grant from the Florida Division of Historical Resources. And the second stage of work set out to reconstruct the paleo-environmental conditions at the site, and at the same time provided us a lot more data on site activities, more radiocarbon dates. I think we're up to 32 radiocarbon dates now. So much of the site is fairly well dated. And while I thought I had a handle on things during the first stage of work, my thinking has changed a bit since the second stage of work. So second stage of work, definitely wanted to go out and get paleo-environmental data in order to figure out what the landscape looked like, how it changed over time, with the purpose of using that data as a control against which to understand human behavior. Were human beings at the site merely responding to the environment, or are there other things at play? And specifically, I wanted to know why mound building stopped. I got a pretty good idea why it started, but why did it stop seemingly abruptly around 4,700 cal BP? And so I wanted to see if environmental factors came into play there. So this map shows where our investigations from the second stage of work. We put in some shovel test pits across a landform up there in the top left part of the site. We put in 2 additional test units, one on the inside, one on the outside of the shell ring. We picked an area between mounds 2 and 4 for sort of moderate density shell deposits to test there. Threw in a shovel test pit in mound 3 because I really needed to know how old that was. Test unit 10 is on a shell ridge northwest of mound 5. There was a lot of vivipara shell on the surface, which is a freshwater snail. And so I wanted to know why there was so much shell there. So we put in a test unit there. Test unit 15 is over to the southeast of mound 6. It's a high density shell area, but it's not mounded. Test unit 11 is on the shell ridge. That's sort of east of mound 8. It is an artificially built ridge. And it transgresses sort of in a perpendicular fashion the natural alignment of the paleodunes. Test unit 16 is put in a weird little feature. It's a mound, but it doesn't have a lot of shell, and it doesn't have any diagnostic artifacts, but I'll tell you more about that in a minute. It's unusual. And then we put in test unit 17 at the south ridge, which is a relatively high elevation, somewhat human modified or enhanced ridge. So they built up the dune with shell. So they increased the topography there. And so I wanted to see what that was about. And from those different testing areas, we got a lot of data that's helped clarify the paleoenvironmental conditions at the site. Our first round of work, oh, there they are. I'm sorry. Before I go on to that, another map. We designated 2 new mounds. We have mound number 12 up here at the north end on this landform. It's a big old midden mound. And then we've got mound 11 down here in between mounds 8 and 9. It's also another little mound. So now the site has a total of 12 mounds to date. So the environmental data collection proceeded as part of our excavations of the site, but also specialized field activities designed specifically to collect environmental data like sediment cores out in the Tomoka Marsh. We got a lot of data we use in paleoenvironmental reconstruction from our column samples, and I'll discuss those when we get to those. All right, so first things first. In 2016, we did a sediment characterization survey across the core of the site. So those areas that are basically located in close vicinity to the shell ring and all the known mortuary mounds, we cored from Strickland Creek or the edge of the paleodune in the marsh eastward until we had at least 3 negative sediment cores in most cases. The purpose for this was to help aid in our placement of excavation units so that we could better target our excavation efforts in locations that are likely to provide the kinds of data that we're interested in. Specifically, organically enriched soils that are likely to provide carbonized plant remains, well-preserved zooarchaeological specimens, and the like. And in the process, came to realize that site deposits, very, very narrow, anywhere from 20 or 30 meters up to approximately 100 meters, but very often less than 100 meters. And there's also concentrations of greater and shell density separated by areas of lower shell density, which is pretty interesting. And there's some patterns in terms of time transgressiveness of site occupation. In other words, the southern half of the site, it was occupied earlier, and the northern end of the site was occupied later, and everything else sort of falls in between. So for the zooarchaeology, and I've got my notes here. Had to go make some notes so I don't forget things. We collected column samples from all of our excavation units in the first phase of work, and I think 3 of our excavation units from the second phase of work. And not for nothing, if there's a graduate student out there who wants to investigate coastal late archaic through St. John's period archaeological deposits, I've got column samples for you. I will make all my other data shareable for you if you do a more intensive and widespread analysis of zooarchaeological remains from the site. shameless pandering. If you want to do that, hit me up. But Zoho Archaeological analysis showed some interesting features. Generally speaking, in terms of an emphasis for subsistence practices, not surprisingly, it's an aquatic orientation. And the species that were utilized through time from the beginning of the Thornhill Lake phase to the end of the Thornhill Lake phase, and even later in St. John's, are fairly consistent. Although during the Thornhill Lake phase, there tends to be denser vertebrate fauna deposits compared to the St. John's 1 and 2 components. Overall, herring, especially menhaden, shad, and mullet, were the principal fishes taken probably through mass harvesting techniques, including nets. And I'm pretty sure I omitted the photo, maybe I didn't, but we did have a net mesh gauge recovered from the site. Other things that were recovered, catfishes, trout, drums, sharks, and rays. But in addition to those aquatic resources, or those marine and brackish, there's also freshwater. We had sunfishes, sunfishes. Yeah, sunfishes were the most abundant type there, especially the red-eared sunfish, also called the shellcracker. And that's important because their favorite food are freshwater mollusks, freshwater snails. And that fits in really well with the fact that we recovered from Thornhill Lake phase deposits, freshwater mollusks. And I'll come back to that later. But we also had North American catfish, gar, bowfin, largemouth bass, and black crappie, I believe. So the fish that were the primary foci of subsistence practices were dense schoolers. So you could, they congregate in large numbers. Many of them will swim up freshwater waterways as part of either their life cycle or as part of their range. And so that the fact that they were captured and consumed in large quantities at the site makes a lot of sense. So in terms of environmental change through time, the vertebrate fauna don't necessarily bear that out as strongly as we would have liked. But our colleague and our friend, Arlene Fradkin, who recently passed, thought that maybe that was because we hadn't sampled widely enough, or even sampled, we should have sampled more within the test units, but because of limitations of time and money, we were only able to sample select strata from the site that would have been representative for each major occupational zone. So there's a chance that the data that we're looking for that would show that freshwater to brackish to marine transition that I believe happened, we'll have to do more work on that front. But overall, Arlene's conclusions was that the aquatic environments in the vicinity of the site provided a very stable resource base that the site's inhabitants could rely on for millennia. All right. On a related note to the zooarchaeology, dead snails do tell tales. And one of the things that really struck me the first time I ever went to Tomoka was just how many freshwater mollusks there were at this site. And that in itself is highly noteworthy. I have combed the published and the unpublished archaeological literature for Northeast Florida, and in only one instance do I find a reference made to any freshwater mollusks in a site, and it comes from the Crescent Beach Midden up in Flagler County. Prior to modern land alterations, the back dune areas of the East Coast would have had a pond and marsh ecosystem. It would have supported, and probably did support, substantial colonies of both freshwater mollusks and fishes and the like. And so that we find them at coastal sites shouldn't entirely be surprising. But it's the sheer density of freshwater snails, mainly viviparous, the banded mystery snail, but also apple snails and freshwater mussels, in addition to mesa ramshorn and alemia and other freshwater snails, that is so unusual. And so one of my former students, now a friend and colleague, Stephen England, who's a graduate student at FAU, did an analysis of the freshwater snails at Tomoka, and especially from units 1 and 5 on mounds, 1 and 4 respectively. because they had what I thought at the time was the complete representation of the Mount Taylor occupation from about 4,900 to about 4,800 and a little bit later Cal BP. And so that's where our samples came from in his analysis from the column samples. They were 50 by 50s in the northeast corner, 1/8 inch screened. And just to give you the long and the short of it, freshwater snails show up at the beginning and they peter out around 4,800 Cal BP, although they do persist in lower numbers up until about 4,200 Cal BP. So what do those mollusks tell us about the environment? Well, in stage 2, I mentioned we had a test unit 10 just to the northwest of Mound 5 that had a lot of vivipara in it. So we put an excavation unit there and it got really weird in the best possible way. Unexpected results that were also, really informative and kind of intriguing. And so over here on the right is the test unit, let's see, it's test unit 1 in Mound 4. That was our early deposits of vivipara from the site. And test unit 10 over here on the left represents our later freshwater mollusks used at the site. So basically, you've got a mixture of freshwater mollusks and marine mollusks, the Donax clam, sometimes called coquina clams. And they persist until 4,200 Cal BP, which is technically not Mount Taylor and not technically Thornhill Lake phase. That's very much in line with the orange period, right? So where's the fiber tempered pottery? In 8 years of field work at Tomoka, we haven't found one stitch of orange fiber tempered pottery. And it appears that the folks living here, while contemporary with the orange culture of the Northeast coast and the St. Johns River and elsewhere, they didn't participate. Or at least the site wasn't a place where you make and use pottery. Conspicuously absent are brackish species, oysters, marsh clam, and hard clam. They are not at the site until St. John's 1. And when we do find oyster, it's often fragmentary, water-worn, and probably a secondary acquisition in the process of mass collecting Donax. So the mollusks are hinting suggestively that there was a freshwater environment in the Tomoka River and Tomoka Basin up until about 4,200-ish Cal BP. I'm going to return to that with other data sets in a moment. Moving on to Geo Archaeology, my friend and colleague Sean Norman, the interim director of the Gulf Archaeology Research Institute in Crystal River, very courageously paddled out in canoes into the Tomoka Basin and up the Tomoka River to collect sediment cores for looking for evidence of a transition from a freshwater to a brackish to a marine environment. And as such, he brought with him PVC pipe. He drove into the ground, removed cores. Those cores were mainly from the basin and marsh and along the river, but also 2 that were adjacent to the site in marshy areas that were probably wet in antiquity and remain so today. And those cores were split, they were analyzed. And although I would like to report that we found exactly what we were hoping for, we did not. What we did find is that there was a lot of historical alterations to the river drainage as a result of land clearing, changes to water flow and inputs, and likely agricultural activities occurring further upriver and associated with farmlands bordering the Tomoka River. The deposits closer to the site produced inverted radiocarbon dates. We had old dates on top of younger dates, which is probably a result of geomorphological processes, erosion of older deposits that are on the land into younger deposits that were deposited in the marsh itself. So not what we were hoping for, but in future work, we should redouble our efforts to seek out and find that evidence of the transition from one ecosystem to the next in the river. All right, paleoethnobotany. Some interesting results here, and they're helpful for the big picture, but unfortunately not so helpful in regards to the plant foods in people's diets. More helpful in documenting the kinds of wood species that were used and available in the local environment. So Lee Newsom of now Flagler College was kind enough to be our paleoethnobotanical consultant on this project. And initially, when we began the work, we had the bright idea, or rather I had the bright idea, and she humored me, that I would collect bulk samples from specific strata for paleoethnobotanical analysis. And after processing a couple samples, she informed me that they were producing almost nothing in the way of botanical remains. So we abandoned that approach and instead focused our efforts on feature contexts, which are more discrete and produced, fortunately for us, more botanical remains, but also macrobotanicals collected in the course of general level excavation. So if we saw any charcoal, we bagged it all, and that paid off. So what did we learn from the paleoethnobotany? Well, as it turns out, pine was the most common wood used for fuel at the site. From both feature and general level excavation contexts, there were even little masses of melted pine resin that were present and in our samples from both features and general level excavations. Other woods included live oak, other as yet unidentified oaks, and palm, but also, and interestingly, possibly hickory and traces of juniper. So that's just from the feature context. When you look at general level wood, it confirms all of those, but also adds persimmon, red bay, and blueberry. So in terms of the edible plants at the site, well, we've got oak, we've got hickory, but we also have persimmon and blueberry. Regrettably, there were no charred squash rinds or seeds found in our deposits, although it is widely known that folks from the Thornhill Lake phase and Mount Taylor, and even earlier, had squashes available to them. Unfortunately, and as is common at open air sites like this, outside of thermal features and outside of carbonation or subaqueous deposits, you're probably not going to have that kind of preservation. So what did all of this tell us? Well, essentially, the composition of the overstory of the trees is the same now as it was in the past. If you go just 50 to 70 yards from the edge of the marsh inland towards the east, you eventually come to pine forest. Along the fringe of the marsh is where you have your live oaks, your hickories, and your palms. So the species composition is very much the same. The woody understory, very similar. So what we were able to discern from our paleoethnobotany is that the past environmental conditions, by virtue of the proxies that we have represented in fuel wood and food remains, very much reflect what is there today. Now, maybe you see these interesting objects here on the screen to the right of the feature. Well, that feature is feature 1. Is at the base of test unit 10. It was radiocarbon dated, I believe, 4,500 to 4,700 cal BP. So it's like at the very end of the Thornhill Lake phase. And within the feature, there are pieces of pine wood that have drilling from both sides. And that was a very exciting and unexpected find. And Lee Newsom interprets those as being fragments and remnants of fire starters for creating friction fires. But that's speculation. It could also be that they're burnt up pine wood beads. Who knows? Regardless, they are carbonized pieces of worked wood that were fortuitously preserved. Feature 1. Okay, now coming to the pollen analysis, which is very informative and actually told me what I wanted to know. Or at least it confirmed my hopes and aspirations. And I have to give a thanks to Kendall Jackson for conducting that analysis and making my paleoenvironmental reconstruction dreams come true. So what did we learn? Well, 2 test units were sampled, and we sampled macrostrata. So we went down to the paleo dune at the base of units 14 and 16, collected samples. We went to the midpoint of the Thornhill Lake phase deposits, took sediment samples from that. And then we went to the St. John's period deposits, dominated by oyster and mercenaria, and took samples from those. And Kendall looked at the pollen and found some very interesting things. Arboreal pollen, surprisingly less than you might expect in most cases, but the presence of so much fungal spores suggests that there was in fact a lot of rotting and decomposing leaf litter, which implies an overstory confirmed by the paleoethnobotany. But let me just fast forward to the other one over here. Test unit 17 is on the South Ridge. It's a fairly early deposit. It may be one of the earliest deposits at the site at around 5,100 cal BP. The paleo dune is that strong brown sand at the bottom there. We took a sample from the middle of the shell deposits from Mount Taylor, and then one from the St. John's period. And I'm gonna bottom line it for you here instead of spending too much time going over the specifics. But basically, the paleo dune had such highly weathered and fragmented pollen remains that it wasn't really diagnostic. The pollen was too damaged and too heavily weathered. That's a bummer. However, the good news is that the midden deposits associated with the Thornhill Lake phase had fresh water marsh grass pollen present. And that makes me very happy. And it's mostly sedges. So the freshwater forbs are present in the Mount Taylor Thornhill Lake phase deposits, and they're pretty much absent in the St. John's deposits. There's sedges there, but those are tolerant of brackish and conditions, whereas the freshwater species are gone. So in a very, a big picture way, very coarse-grained analysis, prior to St. John's, there was freshwater marsh grasses very near the site. And the nearest freshwater marsh would have been, 50 yards to the west at the Tomoka River marsh. So that was great data. I'm very happy with it. And as it turns out, some additional pollenological analysis, phytoliths from shell vessels that I'll talk about, coming up, actually had the same kinds of grass pollens from marshes. So it's been confirmed by other data. Now, I don't want to spend a whole lot of time talking about artifacts because we found some, but that's not exactly the focus of our work. And also, embarrassingly, we didn't find a lot of cool stuff, except for a couple of things, but I'll come to that in a minute. Our super impressive assemblage of lithic artifacts, I was heartily disappointed. So we have a distal biface fragment, top row from left to right, distal biface fragment, a biface stem fragment, a biface barb fragment, a little hammerstone, bottom row from the left, a microlith, distal end, microlith, proximal end in the middle, and then our little coquina abrader. That's it. That's all that's all of the chipped or ground stone that we found at the entire site. I mean, there's some chert flakes too, but there's only 47 of them. Bone tools, more plentiful. This is a selection of some of the more interesting specimens. Top left concentration are proximal fragments of pins. Bottom left are medial and distal fragments, complete specimen in top center, a weird one adjacent to it. Top right, we've got some sort of weird shaped bone plummet looking thing, a pendant maybe. And then there's the curved bit with the circumferential groove, and I have no idea what that is. Down in the bottom right, you've got a piece of scored and snapped deer long bone, and then my favorite artifact from the entire second stage of work is there in the far bottom right, and it's a porpoise tooth that has had flakes removed from its enamel to produce a sharp wedge-shaped tool. Now, how amazingly awesome is that? That's my favorite tool from the entire site. Shell tools, underwhelming. You would think that a site next to the Atlantic Ocean would have a lot of shell tools, and you'd be wrong. What we've got is a tiny little awl in the upper left, a bead top center, net mesh gauge on the top right, and then two Buzicon column whorl tools, and then our like real shell tool. It's a Queen Conquer Strombus gigas adze. That's the most impressive shell tool that we have from the entire site. Precious few shell tools, and I'm kind of disappointed. Pottery, also underwhelming. There's not a lot of pottery at the site. We have a little bit of St. John's in size from predictably the St. John's 1 context. Sand tempered plain, St. John's check stamp. We do have a tiny trace of St. John's too, and sand tempered plain. That's our main ceramic type. Again, there's not much pottery there, and it's all with the much later components post-dating 3300 Cal BP. We also had historic artifacts. Test units 15 and 17 towards the southern end of the site produced cut nail shanks with wrought heads. It also produced a little bit of lead sprue and a little bit of container glass. I was hoping to find some British plantation deposits at the site, but it turns out it's probably early 19th century and territorial period. Second Spanish territorial. Worth following up in future investigations, but I figured it was worth sharing since it was kind of unexpected. Found nothing like it in the first stage of work. All right, a summary of the environment. Essentially, the terrestrial environment is much like it is today. Historic land use alterations notwithstanding, similar plant communities have reestablished themselves, and that is borne out by both the pollen analysis and the paleoethnobotany. Now, the aquatic environment, that's more complicated. It appears based on the pollen and the freshwater mollusks that it was a freshwater environment up until sometime around 4200 Cal BP. After that, in deposits at the north end of the site with later radiocarbon days between 45 and 4200 Cal BP, ostensibly orange period, there's still freshwater snails, but they're a lot smaller and they're not as abundant. By St. John's 1, about 3,300 Cal BP, people come back and they're eating oysters and hard clams and distributing a very thin midden deposit, generally about 20 centimeters across the site. Now, we do have evidence for sea level rise in the establishment of the brackish estuary by about 3,300 Cal BP, but I think it starts earlier. And although sea levels are higher earlier, you don't see the effects of that in the Tomoka Basin and River. And while that is counterintuitive, there is some data from the St. Mary's River to support that the impacts of sea level rise on freshwater rivers and estuaries was held at bay by, at the same time, greater rainfall patterns, putting more water into the aquifer, creating greater discharge. And essentially, the sea level rise wasn't sufficient to back up into the St. John's River. And you have, during the Thornhill Lake phase, evidence for greater water inputs across the state, leading to higher discharge levels in many of the first order magnitude springs. So there's some evidence that the sea levels were not sufficiently high around 4,600 years ago, 5,000, to have impacted all the way up the Halifax River and into the Tomoka Basin. So, while that is the conclusion that I have arrived at with my current data, we still need more data. And I'd like to, in the future, be able to pursue those more thoroughly and aggressively. All right, so that's the environmental bit. Now we're going to talk about ritual and mound building, because I got a lot of things. I got a lot of thoughts about what's going on at the site. So with regard to ritual, I'm going back to test unit 10, the shell ridge north of Mound 5, which is later than I expected, but has some really interesting stuff. The first day of excavation, my friend and colleague Stephen and I came across a Buzicon vessel fragment at the interface of the overlying sand at the top of the shell ridge and the Donax midden, which is associated with the Thornhill Lake phase. And I noticed right away, there's residues in that thing. So I got real excited. I texted my friend Asa a picture, and he had some suggestions for me. And so we mapped it in situ, collected sediment samples around it, and I decided that I wanted to do residue analysis on this thing. Also notice the bottom right-hand photo that there's some graying of the shell and a rectangular fracture. That's pretty common in Buzicon vessels, in this case, Buzicon Carica, Nabuwelk, from being exposed to fire. All right, so that's vessel 1. Then there's vessel 2, which we found adjacent to a hearth on a little berm of sand resulting from the digging of the hearth, and spotted the siphonal canal sticking out of the wall. And after we had photographed and profiled, we dug in, recovered it, pulled it out, and sure enough, it's a Buzicon vessel. It's got soot on the exterior, rectangular breakage. We collected it and bagged it a sediment sample and kept the sediments from the interior preserved in case that would have been necessary for additional residue analysis. So while I was digging, I was forming hypotheses. And the main one that I was interested in is, what were these things used for? Let me give you some stratigraphic and temporal context here. Vessel 1 at the very top of the shell deposits, vessel 2 at the very bottom of the deposits. We've got radiocarbon dates that are, fairly close in age, between like 12 and 50 years. And I rounded these dates up, but it's between like 10 and 50 radiocarbon year, or 50 calibrated years. So it's a very short time span that those deposits formed. And although I didn't mention it and we never did the Zoho archaeological analysis on it, I can say that anecdotally, in the middle of that test unit, we had some weird bones. We had porpoise or dolphin, sea turtles, a wolf, a bear, and either a bobcat or a Florida panther. We had some weird stuff going on there. Oh, and sharks. Really interesting faunal assemblage. So just based on the stratigraphy and before I had the radiocarbon dates, I was already thinking, man, there's some interesting stuff going on here. And I immediately thought of, because archaeologists do this, it's got to be, or maybe could be, ritual in nature, right? So you have a dedicatory ceremony and you have a closing ceremony or ritual for activities associated with mortuary activities on Mound 5. Turns out Mound 5 is older than the activities occurring on the ridge. So that opens up the possibility that folks who are Thornhill Lake phase descended, but living in the Orange period and not making orange pottery, were conducting rituals at ancestral locations and maybe even burying the dead in older mounds. That's a lot of speculation, but that's kind of what I think was going on. But regardless, we did some analysis on the residues. And my hypothesis was that perhaps these cups were used, based on the work of Asa Randall and Zach Gilmore, were used in association with the preparation of ritual teas. And the black drink is familiar to folks in the Southeast and in Midwest, associated with Mississippian groups, associated with contemporary indigenous communities. And so I thought, aha, here's a hypothesis. This was used in the preparation of black drink. Let's test it. And so I collected samples of Yaupon holly, submitted them along with my shell vessels. We had a profile from the Fournier transform infrared spectroscopy well, let's compare these things. So we have a baseline of the Ilex vomitoria and the most diagnostic attributes of it, and compared that to what we found in the vessels. So number one, caffeine. Nope. So already we struck out with Yaupon holly in the black drink. Other compounds, nope. This is definitely not made, was not for brewing the black drink. However, it did have an aromatic benzene ring, which is associated with aromatic plants. And so one thing we can say is that there was some kind of tea prepared with fresh water, because there were freshwater sponge spicules in the vessels, but also members of the sunflower family, as well as, get ready for this, fragmented human hair were present in the vessel at a microscopic level. So while we didn't find evidence of the black drink ceremony going back, 4,500 to 4,700 years, which would have made me Southeast archaeology famous, such is not the case. What I do have, however, are people brewing teas with aromatic plants. I think the best candidates for that would have been wax myrtle and red bay. If you have any idea of other possibilities, please feel free to let me know. So with respect to ritual, we have some things going on at the site that happened after a mortuary or after the mound construction during the Thornhill Lake phase. And now we come to migration. And I have 4 sources of data for this that I'm going to go over briefly. Essentially, mound construction is one. Folks at Tomoka followed an architectural grammar established in the St. John's. Cooking technology using indirect heat, stone boiling. Production and use of the expanded base microlith, and then riverine foodways, especially freshwater snails. I'll go over those sequentially. So in the St. John's, you have during the Thornhill Lake phase, people's using older loci of shell mounding for the construction of mortuary mounds by the addition of multiple layers of sand on those mounded deposits. You find that also at Tomoka. And of course, you can say, yeah, they're just piling it up over the shell because there's shell there. That could be right, except Mound 2 has a deliberately prepared shell platform completely absent of mounded or unmounded shell around it, and they built a sand mound on top of it. So we actually have a case where in the absence of already pre-existing shell deposits, they made one, about 4860 cal BP. So they're following an architectural grammar in the St. John's, and all 4 mounds, 3 of the 4 mounds go up in pretty short order. Mound 6 is the youngest at about 4,700 to 4,400 cal BP, but there's a greater standard deviation on that date because it's an older date and it was done on shell, and so it got a greater standard deviation. So the dates are not in sync with the new ones. I'd love to redate it, but that costs money. Anyway, stone boiling. There's evidence for stone boiling at Thornhill Lake phase sites in the St. John's. At Bluffton, Bullen describes burned areas chock full of fire fractured limestone and burned shell. Ken Sassman at Blue Spring Mid B has burned limestone in association with shell deposits. I had trace amounts at Thornhill Lake. There are also, if I'm not mistaken, at the Groves Orange Midden, there's also some fire cracked limestone, but also fire fractured cooking balls of clay there as well. So there is a history of stone boiling in the St. John's. And after combing through the literature of Northeast Florida on Mount Taylor and Middle Archaic sites, I can't find any mention of fire cracked rock. Even in sites that are less than 10 miles away, the North Midden, FL 215, during the phase 2 and phase 3 excavations there, and I contacted the report author, there was no fire cracked rock. So even just a few miles up the coast, in a contemporary site, they were not practicing this. Here's some of our fire cracked rock. It's limestone. There's a fresh sample on the right, and there's a reddened and graying sort of, thermally damaged collection on the right, or left rather. And I have samples from Edgewater in southern Volusia County that are dead ringers for the stone that we have at the site. What's in the immediate environment around Tomoka, to my knowledge, is mostly Anastasia limestone, which is basically the same kind of coquina rock that St. Augustine is built out of. Expanded base microliths, very common in St. John's River context in Thornhill Lake phase sites, but we also have them at Tomoka. They're sad, they're small, but that is also what we could say generally about the lithic technology at Tomoka. It is sad and it is small, which is heartbreaking for me. But the lithic economy there is based on, retouch flakes largely from late stage biphases. So all the flake tools and all the microliths are like extra small because the raw material packages arriving at the site are extra small. And then we come to the snails. In the Thornhill Lake phase deposits, it's dominated by donax. It's just chock-a-block full of donax shell. You also get some water-worn arcs, cockles, hooked mussels, and sometimes mercenaria and oyster fragments. But the other main mollusk are freshwater snails. And the St. Johns River is well known for its extensive shell mounds made from these things. There's some discussion and debate about whether or not this is daily fare or feast food. And there is some stable isotope data to suggest that it is more of a feast food. But I would still say that we need more information on that. However, the pattern of using freshwater mollusks persists at the site, even in the face of vast numbers of donax, which you can collect in huge quantities in a short period of time, versus of having to collect the vivipara, which would have been bottom dwelling, maybe in large colonies. Who can say they're extinct? So we really have no basis of comparison to go off of in terms of contemporary populations. But a riverine orientation, including a heavy reliance on mollusks, fishes, and then the pesky persistence of the vivipara. They would not be a high-ranked food resource if we're looking at it from optimal foraging and behavioral ecological perspectives. You get much more of a return for your time in terms of kilocalories if you go and get donax from the beach. Just anecdotally, I collected almost 5 gallons in about 10 minutes using a 1/4-inch Archaeology hand screen. So, I mean, with low levels of technology, you can collect a bunch of those things. Oops. All right. So to sum up, you have a lot of influences from the Middle St. Johns River Valley converging at Tomoka, which is my reasoning behind why I think that at least a portion of the population who showed up there come from the St. Johns River Valley. The architectural grammar, the technology, and the foodways all point suggestively to it. And it is, I think Geoffrey Coe would call a site unit intrusion, where these folks, probably through pre-existing alliances, in contact with folks on the coast, maybe along lines of kinship, were able to migrate to the coast and establish a community at Tomoka, which diverges in those areas from other, what you might call coastally indigenous folks who were living there prior to the arrival of the newcomers. So in summary, Tomoka residents probably migrated from the St. Johns. I feel pretty good about that based on the foodways and technology. The terrestrial environment during the Thornhill Lake phase when mound construction began is similar to modern conditions. The river and basin were freshwater during the Thornhill Lake phase, becoming brackish around 3,300 cal BP. Freshwater mollusks are locally extinct around 4,200 cal BP. And mounding ends by around 4,700 cal BP. But it appears that there was a transformation of monumental architecture and rituality that was similar to what occurred in Thornhill Lake phase, but they weren't building burial mounds. I think they shifted to using burial mounds, but they began to engage in the ring architecture that folks further up the coast were engaged in at that same time. But the big divergence is that these folks were not making pottery. There's Orange period sites around Tomoka, but there's no evidence of Orange period pottery at Tomoka. And elsewhere, both on the coast and the St. Johns, people's engaged in ritual activities at Silver Glen, Groves Orange Midden, and various shell rings up the Atlantic coast were using pottery within those contexts. So I think, in a way, the inhabitants of Tomoka, about 45 to 4,200 cal BP, represent, to borrow a term from Ken Sassaman, resistant traditions. they opted out of the fancy orange pottery of their neighbors and chose a more traditional way of preparing food, which is stone boiling in organic containers, even though they'd adopted the ritual or architectural forms of folks who live further up the coast. Now, what am I going to do in the future? Take a break. I've done a lot of work at Tomoka. I'm moving on to other projects. I'm writing up articles and stuff like that, focusing on my research in Kentucky. I got sites I got to write up here too. But in the short term, I do want to go back and test the Tomoka shell ring. That is a really interesting question about why it's later contemporary with orange, but there's no pottery. That requires further investigation. So in a couple of years, I hope to go back. But then there's stage 3 of the Tomoka Archaeology project, which is going to require a lot of money. I would bid hope for at least $250,000 to do the work that I plan to do, which will involve block excavations, more zooarchaeology, more archaeobotany, more sediment cores, and more studies of the paleo environments and artifact source identifications, which I do some of. And then the finale, writing a book about Tomoka and the other Thornhill Lake phase mounds and bring it all into a nice cohesive body of work and then publish it for the world and use that to get promotion to full professor. That's it. That's all I got for you today. I'd like to acknowledge some folks, the Florida Department of State Division of Historical Resources for their permits and their special category grant. Thank you very much. Paleo Research, Linda Scott Cummings and Paul Miller did the analysis of the shell vessels. Park managers and assistant manager Phil Rand and Joe Isaacs have been big supporters. They have been such great boosters and facilitators of this work, and I'm forever grateful to them. My colleagues and co-authors, Sean Norman, Arlene Fradkin, Lee Newsom. Oh, Sean Norman got second billing. I got billed twice. Good for you, Sean. Kendall Jackson and Tracy Lovengood. And then all my field folks. And then the other people who made life enjoyable while we were out at Tomoka. Jim's RV, Tia Corey Tacos, Faux Saigon, and Krabby Chris's, Beachside Barbecue, Rest in Power. They have since closed. And now if you have any questions, I would be happy to answer them.
Thank you so much, Sean. A lot of great work going on, and I feel like
that was a PowerPoint tour de force.
Yeah,
mindful of the time.
It sounds like a really confusing site to work at, but it seems like you've been putting together a lot of solid interpretations. So yeah, if you have any questions, post them in the chat. I know a few already came in. There was a message from Bob that said there's fire-cracked limestone at Big Mound Key in Southwest Florida that's very similar, FYI.
Okay.
And he did have a question about one of your profiles. I don't know if you'd want to pull that back up, but in test unit 10, he was asking if there's a pit in the profile.
Oh, absolutely. Yeah. That was feature 1. And the pit in profile is the one that down at the base, that was after we took it below the level of feature 1.
Okay. And then he was asking for maybe more stratigraphic info from other mounds besides Mound 5. Like, are they all shell, sand and shell, or all sand or conical shaped?
All of the mortuary mounds are dome to conical shaped, and they overlie usually very, I don't want to say maybe shallow or low mounded shell deposits, which was borne out by the sediment characterization survey. But you know, the midden mounds tend to be more elongated, whereas the mortuary mounds are very much dome shaped. At least that's my impression of it. And there is internal stratigraphic differentiation in the shell deposits. And if anybody wants to copy the report, send me an email. I'll send you this giant PDF where those are laid out in the profiles and described in agonizing detail.
Okay. Sherry and Alan asked a question that I was thinking. What is the geological history of the barrier strand between the river and the ocean are there any passes nearby? I was wondering the age of the barrier island.
Yeah, that's a great question. It's Pleistocene. Exactly how old it is, I'm not entirely sure. But that would be something good to do for future work. And one of the speaking of passes, one of the things that I would also like to do is bring on a professional who knows coastal geomorphology and is an expert in that, because there is a very real possibility that there may have been breaks in the barrier island that has been sedimented in by, additional movement of sediments along the coast, as sediments tend to do on the coast. So I'm very interested to see, the bigger picture of that, because I think the nearest inlet is down in Ponce Inlet, much further south currently. But if there were other paleo inlets, that would certainly be good to know.
Definitely. Sue Lewis wanted to know if the site may have only been occupied part-time rather than year-round. That's
a fantastic question. I don't have nearly as much seasonality data, in part because, which is why my shameless plea for somebody who wants to write a dissertation and do on Zoho Archaeology. I would love to have that seasonality data. What I do have is very limited, and it comes from features 1 and 2 from test unit 10. And we used the size distribution of the donax in those features, and they indicate a fall occupation. Now, this is where it gets even better. The paleoethnobotany also recovered hickory nut and acorn fragments from both those features, which are fall ripening, right? So we've got both shells and paleoethnobotany that suggests a fall occupation where feature 1 and 2 are deposited at the bottom. Otherwise, we'd have to look at other indicators for seasonality, and that wasn't in our very modest budget. So those are things for the future and something that I want to do in the next phase of research.
All right, thank you. Yeah, I was going to mention the measuring the donax. I'm glad you did that. I know there's some other studies that do it, and it's free, which is nice.
Yeah, I had one of my students do it for a research project, and they actually got an honorable mention at a university research symposium.
Awesome.
Yes. Thank you, Kelsey.
Okay, so the next question from Aubrey Romer says, can you please speak more about the crazy faunal assemblage? Suspicion.
Yeah, honestly, hi, Aubrey. I would like to speak more about that ridiculous faunal assemblage. Unfortunately, that was one of the contexts that did not get analyzed. But that said, if there's any zooarchaeologists out there who want to write a dissertation, I've got some crazy stuff. But just anecdotally, as we were going through the screen, I'm like, oh man, that's a sea turtle. It's like, oh, that's a dolphin vertebra, dolphin tooth. And then we found the wolf. Like, it's a large canid. And then there was another thing that looks like a bear, another thing that looks like a feline, and sharks and rays. So this is just me doing it on the fly analysis within a 20 centimeter level. But I did go back and look at it again, and yeah, it's still the same stuff. I feel good about those IDs, tentative though they are, and there's still so much more to do out there, which is why I need hundreds of thousands of dollars so I can hire the right professionals to pay them to do their good work at the site.
Thank you. And then Dorothy Moore didn't have a question. She had a comment, and she said, John, this was extremely in-depth analysis of this large site. Thanks for illuminating the very impressive importance of this early site in Tomoka Park.
Not for nothing, Dot Moore is one of my favorite people in Florida archaeology. And she actually did very graciously donate some limestone from her yard, which were my comparative samples.
Awesome. I had a question regarding something you mentioned, isotope data from shells. Were you saying that was from donax or the?
No. I was referring to Brian Tucker's isotopic analysis of archaic period burials at Wendover and Tick Island. So he was looking at isotopes in human teeth. And as I recall, God, I hope I'm getting it right. He didn't think that freshwater mollusks played a significant role in the diets of those people who he sampled. So there's always the possibility of sampling bias. So That's where I got the isotope data for people not eating freshwater snails on a regular basis.
Okay.
Brian Tucker's dissertation for the University of Florida, if anybody wants to look it up and fact check me. But as I recall, I think that was one of the conclusions. And I think there's one burial from who grew up in Tennessee or Virginia based on the oxygen isotopes. So some pretty cool stuff.
Definitely. And then a question regarding the Tomoka ceramic type. Is that named after the river or the site or neither?
The Tomoka ceramic type, there isn't a Tomoka ceramic type. The ceramic types that we found were St. John's, sand-tempered plain, St. John's check stamped, St. John's incised. That's really all we have. But the orange period ceramics that are diagnostic of the orange period are named after Orange Mound in Orange County.
Mm-hmm. And then a question from Tom Schofield just came in. Clay vessels seem like a more efficient way to process Donax chowder. Why would they reject the technology?
Yeah, you are 100% right. It is much easier to boil shellfish in a clay pot directly over fire, but people chose not to for some reason. During the earlier part of the Thornhill Lake phase, I mean, that could be because they didn't have pottery. It wasn't invented yet or hadn't been diffused to Florida. So anything prior to 4,700 cal BP is probably pre-ceramic. Could they be steaming it? Sure. Could they be steaming it with hot rocks? Absolutely. So it's either a steaming process. I'm in the middle of writing a paper about this, which I hope to publish in the Florida Anthropologist like in the next year. So I want to explain this in more detail so everybody can read. But long story short, yeah, they could have processed it through steaming pits with hot rocks and organic containers with hot rocks. There's lots of ways to steam a shellfish, but 100%, it's much smarter. Well, not much smarter. It's much more efficient to heat it in a ceramic pot. But there's actually cultural precedence for something similar in the Savannah River Valley, where you have folks on the coast of Georgia and South Carolina direct heat cooking in pots, and you have folks at Stallings Island who are cooking with hot rocks in clay pots. And then you have folks adjacent to Stallings who are living in the uplands, the Mill Branch culture, who aren't cooking with pots at all. And they're all contemporary. And so it's a cultural choice. For whatever reason, people decided, no, that newfangled pottery thing is not for us. It's not how we do things. So I'm resorting to a cultural explanation for that one.
All right, thanks. So I think that's all the questions. And just wanted to say thank you again, John. Great talk. Awesome research at Tomoka.
Thank you.
So thank you, everyone.
Oh, for my students who are logged on, send me an email with your questions for extra credit.